Hello everyone, welcome back to another exercise series for Chapter 7 of our investment course, BUS 325. In this video we're going to be looking at problem number 12, so let's read the requirements together. It says, consider the following table, which gives a security analyst's expected return on two stocks for two particular market returns. And then we have this table here where it gives us two scenarios for the market return and the corresponding expected return for each of the two stocks, one being an aggressive stock and the other one being a defensive stock. So let's see what's required here. A, what are the betas of the two stocks? Now, in order for us to figure out the beta, we already know from our understanding that beta represents the correlation coefficient of a particular stock with the expected return of the market, or a portfolio that is representative of the market. And since we have two data points for each of these stocks, we can calculate the betas, being the change in the stock return for both cases, for the aggressive stock and the defensive stock, per unit change in the market return. And how are we going to do that? We're simply going to represent, first and foremost, each stock's beta. Let's begin with beta for the aggressive stock. Okay. And to find it out, we're going to see what would be the beta if the market return was relatively high or optimistic, okay, which is going to be 32%, and then subtract what would be the expected return on the aggressive stock if the market is relatively low. So if the market is expected to generate 5%, our aggressive stock is only going to generate 2%. Okay? So for these, we're going to take this and calculate its difference and divide it by the difference in the expected market returns. Okay? So that would be 32% minus 2%, okay, divided by 20% minus 5%. We're going to turn to our calculators. That would give us 30% divided by 15%. And that is clearly a double, so that would mean that beta for the aggressive stock is going to be 2.0. Okay. Now we will do the same for the defensive stock, but this time we're going to denote it as beta D, and that would be 14% minus 3.5% minus 3.5% divided by the same 20% minus 5% that is expected for the market as a whole. Okay, that would give us a 10.5% divided by 15%. Now we're going to need a calculator. 10.5 divided by 15, and that would be 0.7. Okay, and that's what's required for part A. Now let's move to the next requirement, requirement B. It says, what is the expected rate of return on each stock if the market return is equally likely to be 5% or 20%? Now the key word here is equally likely. That means there is a 50% chance that the market will generate 5%, and there is another 50% chance that the market is going to generate 20%. Okay? And correspondingly, for each of the stocks, that means there is a 50% chance that the aggressive stock will generate 2%, and there is a 50% chance that the aggressive stock is going to generate 32%. Okay? So based on that, we can either add these together and then divide them by 2, or we can just multiply their total by 0.5. So we'll say expected return on the aggressive stock is going to equal 0.5, which is a probability of 50%, multiplied by 2% plus 32%. Okay. 2% plus 32%, that's 34%, multiplied by 0.5, that is 17%. And we'll do the same for the defensive stock. So the expected return on the defensive stock is going to equal 0.5 multiplied by 3.5% plus 14%. Okay. Turn to our calculators. 3.5 plus 14, that's 17.5 multiplied by 0.5, that's 8.75%. All right, and that is the answer to requirement B. Now let's read the next one. C. It says if the Treasury bill rate is 8%, remember the Treasury bill rate represents the risk-free rate, and the market return is equally likely to be 5% or 20%, draw the security market line for the economy. All right? Now to draw the security market line, we need a few key pieces of information. We know that the beta for the risk-free rate or the Treasury bill is 0. So we have our first point here where beta equals 0 and the expected rate of return is 8%. And then we also know that the market beta is always 1. So if we find the expected rate on the market, we can also draw that second point where beta equals 1 and the expected rate of return on the market equals what we are going to calculate now, because it's not really given. It's just telling us that there is an equal chance that the market is going to generate either 5% or 20%. Okay? So we'll say C. For the risk-free rate equaling 8%, beta equals 0. Okay? For the expected return on the market, we'll do similar to what we've done in part B, but this time for the whole market. So we know that there is a 50-50 chance, so 0.5% multiplied by 5% plus 20%. Okay, so 5% plus 20%, and that is going to equal 25% multiplied by 0.5, and that would be 12.5%. Okay, and beta for the market, we know that it's always equal to 1. So now, knowing these 4 pieces of information, we can draw our security market line. So let's go to the next page here. I'm going to draw a vertical line, which is going to represent the expected return axis, and then a horizontal line, which is going to represent beta. Okay. Our first point, it's going to be somewhere around here, where beta equals 0 and the expected rate of return on the risk-free investment is 8%. So let's set it up right about here. And then for beta equals 1, let's assume it's right here. The expected return on the market is going to be around 12.5%, so I'll add it somewhere around here. I'm not drawing to scale because we don't have squared pages or a ruler here. I'm just trying to approximate to the best of my ability. So going up from beta equals 1 vertically, the point is going to be somewhere around here. Okay. And now connecting these points, these 2 points, we're going to get our security market line. All right. I'm going to write SML right here. Okay. Perhaps also connect these. Now this point represents the market portfolio. Okay. And that would be enough to satisfy requirement C. Let's go back and read. Alright, so part C only wants us to draw the security market line, which we have done. So let's read the next requirement. It says, plot the 2 securities on the security market line graph. What are the alphas of each? Okay, so now we have our 2 securities, our portfolios, the aggressive security or the aggressive stock and the defensive stock. Remember, the aggressive stock is expected to generate 17%, okay, with a beta of 2, whereas the expected return on the defensive stock is 8.75% with a beta of 0.7. So for each of these stocks, we already have their beta and expected return, so we can draw them on the security market line. Let's start with the aggressive one. Beta equals 2 and the expected return is 17. So if we say that beta is somewhere around here, okay, I will draw a vertical line all the way up to the security market line, and then from there I'm gonna have to push this up just a little bit. All right, and that would be the expected return on the aggressive stock equals 17%, right about here. And here beta equals 2.0. All right. And then for the other stock, the defensive stock, the beta is 0.7 and the expected return is 8.75%. Okay. Now, I'm also going to, aside from drawing this, I'm going to calculate it using CAPM, right? So for each of them, let's do it for, first of all, for the aggressive stock before we move on. We'll see what would be the expected return on the aggressive stock using CAPM. Remember, CAPM says the expected return equals the risk-free rate plus beta multiplied by the expected return on the market minus the risk-free rate. Okay, so taking that into consideration, the risk-free rate, we already know it's 8%. Beta for the aggressive stock is 2.0 multiplied by the expected return on the market, which we already calculated to be 12.5%. So that will be 12.5% minus the risk-free rate again. That would be 2 multiplied by 4.5, which is the difference between the 12.5 and 8. Okay, plus 8, that is 17%. Okay, because remember the question here, part D, says plot the two securities on the security market line graph. What are the alphas of each? So for us to find the alphas, we need to see what's the difference, if there was a difference between the actual expected return and the required return predicted by the capital asset pricing model. Okay, so the actual expected return here is 17%, as we calculated in this part. Let me highlight it for you. Okay, and the expected rate of return using CAPM is also 17%. Okay, so that means alpha for the aggressive stock is going to equal, let me first write the formula for you so you remember. The alpha formula is the actual expected return minus the required return predicted by the capital asset pricing model, CAPM. Okay, which for the aggressive stock equals 17% minus 17% equals 0. So alpha for the aggressive stock is 0, meaning that CAPM, or the actual expected return, matches the required return as predicted by the capital asset pricing model. Now let's see if that is the same, or if that scenario is also true for the defensive stock. Okay, so for the defensive stock, we have already found the actual expected return to be 8.75. Let's see if we use CAPM, would that still be the same? So the expected return on the defensive stock using CAPM, 8% plus, remember beta for the defensive stock, it was 0.7 right here. Okay, so 0.7 multiplied by 12.5% minus 8%. That would be 8% plus 0.7 multiplied by 4.5. That's 315. Plus 8%. That is 11.15%. Okay. Now, as you can see, there is a difference here. There is a gap. So based on the defensive stocks beta, the capital asset pricing model expects a stock with a beta of 0.7 to have an expected rate of return of 11.15. But our analysts have provided that the defensive stock here is expected to only return 8.75. Okay, meaning that here we will have an alpha. So alpha for the defensive stock is going to act to equal 8.75, which is the actual expected return, minus the required return predicted by the capital asset pricing model, which is 11.15% in this case. Okay, so 8.75 minus 11.15, and that would be a minus 2.4%. What does that mean? That means on our graph, for beta equaling 0.7, let's say it's somewhere around here, okay, the defensive stock is going to lie somewhere around here, just above the 8%, right? Because its actual expected return is 8.75, so maybe somewhere around here, okay? And because of that, let me pick a different color. Hopefully this will be clear. Okay. All right. Okay. Because of that, this particular defensive stock, let's denote it here to be D, has an alpha, okay, of a negative, just like we've calculated earlier, of a negative 2.4%. Okay, so we can denote that on our graph. Maybe this way. Okay, this is alpha for the defensive stock, which is the difference between the 8.75 and what should be here to be 11.15. I'm gonna raise this up just a little bit. %. Okay. Because based on the capital asset pricing model, this particular stock should generate, or should be required to generate 11.15, but based on the analyst's opinion, it's only expected to generate 8.75%. Okay, and that difference or that gap is called alpha. Okay, this distance right here. Okay, so that would be the answer to part D. Now let's go back and see the last requirement. Part E, it says what hurdle rate should be used by the management of the aggressive firm for a project with the risk characteristics of the defensive firm's stock. Okay, So if the company or if the management decides to go for a project, assuming that the management, that the firm is aggressive, but they decide to go for a project with the risk characteristics of the defensive firm's stock, here you need to consider the project's risk characteristics, right? Because for a company, it doesn't really matter what their overall strategy is. They would consider each project based on its risk characteristics, right? So if the project that the company attempts to go into is lower risk, meaning that it has characteristics similar to the defensive stock, that would suggest that it has lower risk. Okay. And the hurdle rate in that case would be the discount rate that is predicted by the capital asset pricing model. Okay, so we could write this maybe as follows. Let's say E. The hurdle rate is determined by the project's beta, okay, which is in this scenario 0.7, right? And not by the firm's beta. Okay. So the correct discount rate, and when we talk about the discount rate, meaning that this is the discount rate that the company needs to use to discount the expected cash inflows that would be generated by the project in order to figure out their present value. Okay, and based on that present value, they then need to decide whether to go into that project or not. Okay, so the correct discount rate is therefore 0.15%, which is the fair rate of return on stock D as predicted by the capital asset pricing model. All right, and that would be the answer to part E. Now, let's go back and recap, since this is a relatively long question. In fact, this is the longest question that we have selected from this chapter. So let's see what we've done. Just to quickly remind you, we were given this table to show us how would each of these two stocks would react for two different scenarios of the market, scenario 1 and scenario 2. In case the market is expected to generate 5%, the aggressive stock would then be expected to generate 2%, and the defensive stock is expected to generate 3.5%. Whereas if the market generates 20%, the aggressive stock is expected to generate 32%, whereas the defensive stock is expected to generate 14%. Now, just reading this already, we can safely assume that clearly this stock would have a much lower beta than this stock, right? Now, how did we calculate the beta? We simply found the magnitude of the unit change of the reaction of the aggressive stock divided by the difference in the market returns. Okay. Now, here also just remember that you don't need to worry. If you calculate it this way, being the high minus low divided by the high minus low, or the other way around, it will still give you the same answer, beta equals 2. So let's assume if I forgotten this and I instead calculated this part by 2% minus 32% divided by 5% minus 20%, which is the other way around, calculating the low expected return minus the high expected return for the aggressive stock divided by the low expected return for the market minus the high expected return for the market. That would still give you the same answer. It will be negative 30% divided by negative 15%, and in the end, the beta is going to be the same too, right? And then, knowing this, the question told us that if there was an equal likelihood of the market achieving either 5% or 20% return, what would be the expected return on each of these stocks, the aggressive stock and the defensive stock? So we added the two expected returns, so for each scenario, and then we multiplied the total or the sum by the 50% chance. Okay. Then for part C, the question gave us an extra piece of information, being the risk-free rate as represented by the treasury bill rate of 8%, okay, and told us that the market is also expected to, or is equally likely to generate either 5% or 20%. So from there we calculated the expected return on the market. Okay. And the question also assumes that you know that the risk-free rate has a beta of 0. This is fixed. It doesn't change. Any risk-free rate, treasury bill, or any other alternative that you use as a benchmark or as a representative of your risk-free investment would have a beta of 0. And also we know that the market always has a beta of 1. Okay? Because remember, beta represents the correlation coefficient with the market. So the market will always have a 1-to-1 relationship, meaning that if the market goes up by 1%, of course, the market would go up by 1%, right? And then for the next requirement, we were asked to sketch or graph the security market line. And knowing these 2 points, beta equals 0 and the expected rate is 8%, and for the market, beta equals 1 and the expected return is 12.5, we managed to plot those 2 points and then connect them with the security market line. Okay? And then the following requirement was to plot the two investments, the aggressive stock and the defensive stock, on the same graph. We saw that for the aggressive stock, beta equals 2 and the expected return on the aggressive stock is 17%, and we found that the stock is going to lie on the security market line, meaning that the actual return is the same as what's predicted by the capital asset pricing model. Okay, we calculated the expected return on the aggressive stock using the capital asset pricing model. We found it's also 17%, which matches the actual expected return. And based on that, we can state that alpha for the aggressive stock equals 0. There is no alpha. Remember that alpha represents the abnormal returns, okay? Meaning the returns that are not predicted by the capital asset pricing model. But when we came to do the same for the defensive stock, we saw that the actual expected return on the defensive stock was 8.75%, whereas when we try to estimate it using the capital asset pricing model, we get 11.15%. So there is a difference of minus 2.4%, which represents alpha for the defensive stock. Hence why we plot the defensive stock here, and we state that this gap here represents alpha for the defensive stock. And finally, the last thing the question wants us to evaluate, saying that if the company has an aggressive management or aggressive strategy and they decide to enter a project that has similar risk characteristics as the defensive stock, what would be the hurdle rate? And we say that the hurdle rate is determined always by the risk characteristics of the project. And since it matches the defensive stock, that means it's low risk. It's a low risk investment, and based on that, it would have a hurdle rate similar to stock D, the defensive stock, which is 11.15%. Okay. I hope you enjoyed this exercise walkthrough. I hope you found it useful. If you have any questions, please feel free to ask down in the comments. I'll try to answer any questions that you may have. And until I see you in the next video, take care.